Hello, I want to show you some refactoring that I recently made in a test case that wasn't quite optimal. And I will show you what this test case does. So this test case here gets some input. Yeah, there's a lot of data. And then there is some output data. And the test case uses an indicator here with an interval of 5. Meaning that this indicator will only give back results after 5 inputs have been inserted. Meaning that these 1, 2, 3, 4, 5 things need to get in first before this thing produces an output that can be checked here. And because the index length is different between the inputs and the outputs, I used a method here to then shift from the output here the first element, which means it will be removed from the array and then be put here in this expected constant that then is being used to check against. But there are many problems. First of all, I don't like non-null assertions, and I used one here because when I use shift or pop, that modifies an array. And when I modify an array, then it can lead to cases where the array is empty and TypeScript knows about it and then says, okay, the array can be empty, meaning if I remove the non-null assertion, then it can be like number or undefined that is coming out here of that outputs array. Yeah, this is the consequence if I don't use the non-null assertion because the array is not immutable. So first of all, let's make that array immutable. We can do that by just adding asconst here. Now it's immutable. Now I'm not allowed to use the shift method anymore on it. And that is a good thing. We'll come to it in a bit. I just now need another technique to access the elements here. And I want to access them, but not from index 0, but from the case where I have already like 5 inputs here. So the number 5 here plays an important role because I would like here to still use a for loop. And I want to loop through all the inputs, and when I reached 5 inputs, then I want to actually do this operation here and get an output to compare with. So let's add an interval with the size of 5. I will reuse it here. It's also a good technique, right, that number 5 was used already twice here, so it's good then to create a variable for it and reuse the variable as often as you can. And then I need to have an index, yeah, to index basically the outputs here. We can get an index using the Array.entries method. Yeah, I want to show you that in the Brave browser. So an array has an entries method that returns us an array iterator. And through that array iterator, we can get the index. Here we can see that like index and element of array entries. And then we get as index 0, 1, and 2, like for these values here, A, B, and C. Which means that if I go back in VS Code, I will use the same technique here. I will say I want to get the index and the input of my inputs. So here I will call then the entries method. And that will give me now the index that I want to use. And then I can say, okay, my expected item is from the outputs, basically the current index. But remember what I said in the beginning of the call, that we will have already, or we need 5 inputs first before we get an output. So the index will be at 5 already. And this is what I don't want. So I need to subtract here actually the interval from it. Then I will get the right item. Yeah, and let me check if this works. Yeah, it does. Everything is all right. Yeah, and that makes the code already much cleaner using asconst and avoiding non-null assertions and making use of array entries. I also want to use asconst here in my inputs, yeah, to not run into the same problem again that I then modify the array where I actually have measures to avoid modifying the array. Let's talk about another problem that often occurs when using for loops in tests while we are at it. So here we see, for example, that we have some expectations within the for loop. And that's all right for now. Yeah, so for example, if we change here the value to 3, we'll get to see that there is an error being thrown here in our expectation within the for loop. Yeah, so the mistake here is being caught. And if I change it back, then we'll get to see that the test runs successfully. So our test cases are fine, but there are some issues here when, for example, the inputs would be empty. Yeah, then none of this would be executed and the expectations also wouldn't be executed. Let's assume that, for example, we wouldn't have any tests down here. As long as we have expectations after the for loop, it's all fine. But let's assume we would not have these here. Then we can still run the test cases and the expectations, and they are all good. But as soon as we then empty the inputs, we will get to see the following. We'll also get to see a green test run in here because the for loop is just not being executed and no expectation is being triggered. And that's also a mistake that we may want to be aware of. So we can, in this case, with a ytest easily create a spy function to track the amount of for loops. So I can say my call count here is a function, yeah, a spy. And every time I'm in the loop, I will just call my spy. And then at the end of that loop, I can say expect my spy function to have been called. And I can also check for the amount of times it has been called. And it should be called as often, or as much as we have outputs here. So the expectations, and I can say in this case here, it should be of outputs.length. If I have this and I will run the test again, I will get an error. Let us see why. Scrolling down, call count hasn't been executed. Yes, because the inputs is still empty. Yeah, so that's actually what we want to see. Yeah, we want to see that there's something wrong with our test case. So let me just bring back here the inputs. I will just try to not change all the lines here, but the line number 38. This one, we'll paste it. Oh, a little too much here. Now our inputs are back, and if we run the test, we get to see that it has been called 15 times. Yes, because there is here stability. Yeah, so actually there are 5 more calls from the initial interval. And then after these 5 calls, we get to see a stable indicator that gives us some output. So we need to add these 5 initial calls to warm up the indicator, meaning we can here add the interval that we subtracted here when we are going through the expectations. Let me run the test again, and we see it's fine. So this call count technique here with a spy is a good practice if you really want to make sure that your for loop is being executed.